Okay. So here I am writing this one, depression in freezing point, right? Depression, depression in freezing point. Okay, this one you are asking.
Yes, sir.
Freezing point. Okay. So this is just like the elevation in boiling point. So freezing point means what, how we are, first of all, you should know that is what is the freezing point. Okay. If you are, I will ask you freezing point. This is the very simple definition. That is when vapor pressure of liquid becomes equal to what? Equal to vapor pressure of substance in solid phase. Vapor pressure of substance in what? That is solid phase. Solid phase. That is called what? That is freezing point. So if you talk about the water, if you are taking the water, so its vapor pressure, something will be vapor pressure. Its freezing point will be what? That is BP. And if it is the H2O solid, means ice, it becomes the ice. Both the BP are equal. It means that point is known as what? That is freezing point. This is what is called freezing point. Now, if I will ask you some more point, that is, this everything is related to what? The vapor pressure. Vapor pressure. Vapor pressure. So what the point here we have to understand, if you add, what you are going to add? Non-volatile solute. Non-volatile solute. Then one thing is going to happen, very sure. What the thing is, the vapor pressure, that is freezing point, is going to decrease. Okay. So if you add the non-volatile solute, vapor pressure of solvent in solution, vapor pressure of solvent in solution decreases. Vapor pressure of solvent in solution decreases. Okay, this is the point. Now, if I will ask you one more point here, so BP one solvent will be there. That is BP solvent means that is pure state. Another is the BP solution. Which one you are expecting to be greater?
Sir, VP of solvent.
Solvent. So it is going to be high and this is going to be low. This is. Now, if I will write the depression in freezing point. Depression in freezing point. How we are going to represent this one? We are going to represent by delta TF. Okay. Now, just now you said that is the vapor, that is freezing point of the pure solvent. That is TF naught will be greater than TFS. This is the TF naught minus TFS. This is, you can write like that. This is what? Freezing point of solution. FR.
Sir, you can bring the previous slide once again.
Freezing point. 1 second.
Mm.
This one.
Yes.
Done. Freezing point of solution. This is the freezing point of pure solvent. Freezing point of pure solvent. Pure solvent. And this is the depression in freezing point. Depression in freezing point. Now, we need to go look in the NCERT book also little bit. So here they are saying that is delta TF is colligative properties. How can you say it is colligative properties? As it depends. It depends on what it is depend. Depends on number of solute particle. Number of solute particle. Only. Not on its nature. Only. And they are saying not on its nature. So if it anything depending on the number of solute particle, then it is going to be what? Colligative properties. Now delta TF they are saying experimentally proportional to molality. Molality. This is the experimentally. Experimentally it is observed that is delta TF is proportional to molality. So delta TF is equal to KF into what is going to be molality. Molality. Now you must be knowing delta TF is equal to what? KF multiply by molality. What is that is? Moles of solute. Moles of solute divided by mass of solvent in kg. Mass of solvent going to be in kg. Now another point, important point here, you see delta TF. This is going to be what? KF molality means it is going to be, you can rearrange this is. How can you rearrange? The number of moles means W2 upon M2 divided by mass of solvent W1 divided by 1000. This is going to be in gram. So delta TF going to be KF into W2 into this is going to be 1000 divided by M2 into W1. These are the definite. This is the formula.
Sir, what is the meaning of this KF, sir?
KF cryoscopic constant. I am writing in this one on the different side.
The
Delta
previous
TF.
slide is not yet finished. I'll tell you, sir.
Cryoscopic constant. This is
Sir, why
cryoscopic.
it is called
I mean,
KF into M?
Hmm.
Del TF equal to KF into W2. Sir, here W2 means the solute, na?
Solute, yes, yes, yes. Second condition is always for solute and first condition is always for solvent.
So done.
Done. So erasing this one. So we are having delta TF is equal to KF multiplied by W into 1000 divided by M2 into W1. If you are writing each and every one of this one, so delta TF is depression in freezing point. This is the depression in, that is freezing point. This is depression in freezing point. How this is calculated? Delta TF is equal to TF naught minus TFS. What is TF naught? I will ask you. What is the TFS? TF naught? For TF naught is 273.15 Kelvin or 0 degree C. This is the TF naught for H2O. Okay, freezing point of water. Now W2 is mass of what? Solute. Mass of solute. This is. And M1 molar mass of M2 molar mass of what? It is going to be molar mass of solute. Next one, W1 mass of what is going to be? Mass of solvent. Mass of solvent. KF just one molar. This is called molar depression constant. Molar depression constant. Other name is also there, or cryoscopic constant. SCOPIC. Cryoscopic constant. This is also the name. Can I erase this?
Yes, sir, one second. Sir, for water you are writing, na, this one?
Yes, yes, yes.
So done.
Okay. Now, if I will ask you unit of KF. Unit of KF. So how you define unit of KF? So delta TF is equal to KF into M. So KF is equal to, you can write delta TF upon small m. Delta TF is Kelvin. This is what? Mole kg inverse. Mole kg inverse. So what will be there? Kelvin kg mole inverse. This is the unit. KF unit. Can't you understand this?
Yes, sir. Writing.
Hmm. Done.
Done.
Okay, good. So here we are going this one. Let us see if I will say. Yeah, this is the slide. Okay, this is NCERT only, not any other book. So let us see, try and see that is what the NCERT lines are saying about this one. Okay, you are saying that you already read this one, but we are going once more. Okay, there may be some important point that you may missed out. So here we are studying the line by line. So what is there? The lowering of vapor pressure of solution causes lowering of the freezing point compared to that of pure solvent. Means means this line itself alone is saying very clear things. That is lowering of vapor pressure, because you are adding the non-volatile solute, vapor pressure will be lowered. Of a solution, what the term you are using? Solution. The lowering vapor pressure of solution causes lowering of freezing point compared to that of pure solvent. So you got to know delta TF is equal to, it is going to be TF naught minus TFS. Yes or no? We know that the freezing point of substance, the solid phase, is in dynamic equilibrium with the liquid phase. Thus, the freezing point of substance may be defined as the temperature at which vapor pressure of substance in liquid state is equal to its vapor pressure in solid state. Can you understand this one? Freezing point definition.
Yes, sir.
Okay. If you can't, I wrote here. Here you see. Vapor pressure, if you add non-volatile solute, so vapor pressure of solution decreases. Somewhere I wrote here. I might, freezing point. When vapor pressure of liquid becomes equal to vapor of substance in solid phase, that is called what? Freezing point. That is what they are talking about. So you might get this one, right? Now, a solution will freeze when its vapor pressure equal to the vapor pressure of pure solid solvent, as clear from 2.8 figure you see.
Yes, sir.
So you see the vapor pressure of pure solvent, this is the temperature they are talking about. So this temperature is, they are freezing at high temperature something. Now when the non-volatile solute added, so it be freeze a little lower temperature. Yes or no? So between this, whatever is coming, that is called depression in freezing point. This decreasing, now that is called depression in freezing point. This is the solution one, and this with the solvent one. So solvent vapor pressure, initial vapor pressure, you can see the level of vapor pressure is very high, and solution vapor pressure is very less. So different if you are calculating in these two, that is depression and freezing point. How the diagram is, this is the graph, it is like that. Graph, you need to practice this. According to Raoult's law, when non-volatile solid is added to solvent, its vapor pressure decreases, and now it would become equal to that of the solid solvent at lower temperature. So this line, can you make it clear, this one? What the Raoult's law is saying, when non-volatile solid is added to solvent, vapor pressure decreases. Any problem up to here? Are you listening?
Yes, sir.
Now decreases, and now it would become equal to that of the solid solvent at lower temperature. Thus the freezing point solvent decreases. Freezing point of solvent decreases. Now let us see the point, what the point is there. Let TF not be freezing point of pure solvent, and TF is the freezing point of the non-volatile solute is dissolved in it. The decrease in freezing point of solute is dissolved in it. So how we are calculating? Can you see this one? Delta TF is equal to TF naught minus TF. TF is, that is the freezing point of solution, freezing point of solvent. Similar to elevation of boiling point, depression in freezing point for dilute solution is directly proportional to what? Molality, the small m of solution. So how they are? Delta TF proportional to small m. Delta TF is equal to KFM. The proportionality constant Kf, which depends on the nature of the solvent, known as freezing point depression constant. Freezing point depression constant. This is called freezing point depression constant. There is some more name are there. Molar depression constant, that I wrote that one. One more name is there. What is this name is all about? Cryoscopic constant. The unit, the unit is, what is there? Kelvin, kg, mole inverse. Value of K for some common solvent listed in table 2.3. You see the table 2.3, where is this one? So water Kf value, this is, Kf 1.86. Kb value is 0.52, so 1.86. Ethanol 1.99. Cyclohexane 20. Benzene 5.12. So benzene is important, water is important. Two are very important. Chloroform, carbon tetrachloride, carbon disulfide, diethyl ether, and this is 390 acetic acid. But two is important. So benzene you need to memorize. Okay. TF, benzene, not TF, that is you can say KF. Benzene. What is this benzene is 5.12. Okay. KF, what is this one? 1.86. This one you need to know. The remaining, that is not very important. Here see, if W2 gram of solute having molar mass M2 present in W1 gram of solvent produces the depression in freezing point, that is delta TF of the solvent, then molality of solute is given by the equation. This is the equation. That already we have done this one. Nothing to write. Okay. This all the things we have already done. So let us solve the question. Question number 2.9. Okay. Depression in freezing point they are asking, delta TF. Okay. Delta TF they are asking. What is delta TF? KF into M. So delta TF is equal to what we can write? KF into W2 into 1000 divided by M2 into W1. How many gram of ethylene glycol? What their ethylene glycol is mixed 600 gram of water. So KF, we have to write water KF value just now I have told you. How much? 1.86. W2 45 multiply by 1000 divided by M2. Molar mass of ethylene glycol. Can you tell me? CH2OH and CH2OH. 62 something will come. MM of ethylene glycol. See? 24 plus hydrogen how much? 6 plus 32. How much will come? 30 plus 32 is equal to 62. So it is 62. Multiply by W1, 600 gram. 20 cancel out. So what will 2 5 ja 10, 2 3 ja 6, 3 6 ja 18, 3 2 ja 6. Okay. So here is 0.62 multiply by 45. What is multiply by 5 also there? 3 is gone. 62. This 62, this 62 is cancel out. So what will be there? 0.45 multiply by 5. 5 5 ja 25. 5 carry 2. 5 4 ja 20. 22. 2.25 Kelvin delta TF. Can't you understand this one? Hello?
Yes. Yes.
But we have to check the answers also. Can I? Checking the answer. How much is there? This one. 1.2 mole per kg. No. Depression in freezing point, how much is coming? Delta TF. 1.86. No. Here. 2.2 Kelvin. Delta TF. This all the multipliers are there. 2.2 Kelvin. How much we got? Delta TF. 2.25. Can't you understand this?
Yes, I can understand.
They are saying freezing point of
keep this for 1 minute.
Freezing point of solution also asking. So delta TF is equal to TF naught minus TFS. Freezing point of solution if you want to calculate. So TFS is equal to TF naught minus delta TF. Okay. So TF naught is how much? 273.15 minus T delta TF 2.25. Can you calculate this?
Hmm.
273.15 multiplied by divided by subtracted by 2.25. It is coming 270.9 Kelvin. This is so earlier the vapor water freezing 273. Now it will solution is freezing below, that is 270.9. So you can check back this one also 270.9. Got it? Hello.
Yes, sir.
I have given one more questions here. This year the problem 2024 this is asked in the paper. Have you gone through the paper? Have you seen the paper? Exam
No,
paper.
sir.
Then who will see? I will see or what? You need to go in the exam, then who will see? Here you see a solution containing 60 gram of non-volatile solute in 250 gram of water. This is this year paper. This is year 2024 exam. Okay. Total one question 2 marks, one question 3 marks came. So total around I think to 15 marks around came in the paper. A solution containing 60 gram non-volatile solute in 250 gram of water freezes this temperature. Calculate the molar mass of solute. Kf is given. So what the formula? Delta TF is equal to Kf into M. So delta TF is equal to Kf into W2 into 1000 divided by M2 into W1. Now you can plug out the values, whatever the values are there. 1.86 delta TF. First of all, you calculate delta TF. Otherwise, you can't do this one because they are asking molar mass. So delta TF required. So this is TF naught minus TFS. TF naught of water is 273 point how much 15. So 273.15. Vapor pressure water freezes what 270.63. Now you need to subtract this one. 273.15 minus 270.63. 2.52, something coming 2.52. So here we are placing 2.52, 1.86, W2, how many gram? 60 gram. This is the conversion factor, 1000 is conversion. What is else? Molar mass. Which one is there? Molar mass they are asking, man. W1, how many gram of water? 250. Now here we are solving this one little bit going down. You see. So M2 is equal to 1.86 multiplied by 60 multiplied by 1000 divided by 2.52 multiplied by 250. This is going to be 4 times. So 1.86 multiplied by 60 multiplied by 4 divided by 252. Decimal will be cancelled out. Okay, if you are solving this one. So I am solving 1.86 multiplied by 60 multiplied by 4 divided by 2.52. It is coming 177.14. So a round figure, if you are taking 180 gram per mole, it is coming. This is the question here. The answer is also written here. But in this one, this is the answer. Round figure. Understood? No.
Yes.
Okay. If you understood, then you solve the problem.
No, sir. The last thing you're explaining, can you explain once again? And sir, you can be a bit louder, sir. Your voice is not very audible.
I am
Volume
very,
is coming good.
I am very,
Solution
very
is
loud. I am very, very louder, yaar. Nobody can
okay.
with this.
2.10, na, this one. 100 gram of non-electrolyte solution dissolved
Hmm.
in
Hmm.
50 gram of benzene lower the freezing point.
Hmm.
Find the molar mass of the solute. Solute,
Yes.
sorry, solute means we have to find out the M2.
Hmm.
Yeah.
Hmm.
M2 will, 1 second, sir, 1 second. M2 will be equal to this one.
Hmm.
Kf into
Hmm.
W
Hmm.
del TF is also given 0.4. Del
Hmm.
TF into this one. Into del TF into W1.
Hmm. Hmm. Okay, super, super, super. So let's check back the answers here.
Yes, sir. Yes. Should I
256.
erase? Should I erase or what?
No, no, no. You see the answers. So you
It's correct
understood
only.
correct only, no? Acha. Do this one. Do this one.
Sir, actually here in this chapter only problem is that calculations are a bit long. Otherwise, sir, formula based only what I have seen.
Yes, yes, yes,
I've
yes,
done the
yes.
entire thing.
Mm-hmm. Everything is the easy only. Nothing is to worry. Are you doing this one or should I do?
Checking if I can do it.
What you are saying?
Sir, I'm saying that I'm checking, sir, whether I can do or not. I think I can do or not.
Okay, okay. So should I start?
So you do?
Okay. So it's very simple only. What they are saying, 45 gram of ethylene glycol is mixed with 600 gram of water. So W2 is equal to how much? 45 gram. M2 is equal to, just now we calculated now, how much was coming? 62 gram. Calculate the, what is the 600? W1, how much is there? 600 gram. KF is how much they have given? No? 1.86. Okay. Then what they are asking? Freezing point depression, delta TF. So delta TF is equal to, what is going to be? KF into W2 into 1000 divided by M2 into W1. So delta TF value they are asking. KF value 1.86, W2 value 45, multiply by 1000, M2 value 62, W1 value 600. What we can do, 2020 cancel out. So 1.86 multiplied by 45 divided by, so there is the zero will be also there, divided by 62 multiplied by 6. Okay. So this is divisible actually. 6 3 ja 18, 31 time, 0.31 it will come. Okay. And if you divide, this is also going to be divided. See, if I will divide this one, 31 multiplied by 100 multiplied by 450 divided by 62. So what will be there? 6200 will come or what? No, no, sorry. Little mistake. Why 100? 100 will be downside because decimal removing. So this is going to be 2 times. So 450 divided by how much? 200. So 1010 cancel out. 45 upon how much will be that? 20. So 2 2 ja 4. 2 2 ja 4. And 0.5 divided by this is the 10. So 2.25 Kelvin kg per mole. 2.25. Can't you understand this?
Yes, sir. So you keep this slide for one.
Ah, yes, plus right there. Freezing point of solution also they are asking. So delta TF is equal to what is there? TF naught minus TFS. So TFS is equal to what? TF naught minus delta TF. So what is TF naught? 273.15 minus 2.25. So you can subtract this one easily. Let me do 273.15 minus 2.25. It is coming 270.9 Kelvin. So this is reduced. Depression in freezing point occurs there.
Yes. Sir, done.
Done. Now we have to verify whatever we are doing, whether we are doing correctly or not. No? So you wrote the answer, you see, 2.25. The same answer is coming delta TF or the different. Delta TF we here they have given 2.25 correct now. You can say yes or no. And that is solution how much they have given. 279.9. Is it correct?
Yes, sir.
How slowly you are saying? You are saying that is my sound is going very faintly, but your sound is very faint.
They're not coming. My sound is not coming.
Very slow coming. Your is also very slow is coming. Do this one. Can you do?
Yes, sir.
What should I do?
Sir, trying to. Let me read the question once.
You read loudly.
Find the
Hmm.
depression in freezing point of a solution containing 0.520 gram glucose H12O6 dissolved in 80.2 gram of water KF for water
Hmm.
1.86 Kelvin per mole.
Hmm.
So here
Hmm.
we have this one LTF equal to.
Where are you writing? I'm not. It is not visible to me.
So I will write here. Write it. I was actually writing in the notebook.
No, no. Why to use notebook? Is there the hmm.
So the values are given. KF is 1.86.
Hmm.
This one 1520.
Hmm.
M2
Hmm.
M2 water. These
Hmm.
are so C6H12O6.
Hmm.
Molar mass for this one C6H12O6.
Glucose molar mass you need to calculate. Or you should know. 180. Why you are calculating?
Sir, I forgot actually.
No, you must not forgot.
1 80.2. This one is a long calculation, sir. 1.86.
Should I do now?
Sir, I am doing only with this one, this calculator.
You can use the calculator.
67.2. 14.436. Into 520. 967. 1, 2 divided by 0.067.
0.067. This is the Kelvin. Okay,
Yes.
let's check the answer. Whether it is correct or not. Correct one, na? 0.067. Yes or no?
Yes.
Now see this one. This question you try. You erase this one, what you wrote. Wait, I will erase. I will erase, don't worry. Now you see this question, what the question is saying. Find the freezing point. Should I do or you are going to do?
So let me read it, please.
Find the freezing point of solution containing 0.5 mole glucose dissolved in 200 gram of water, given that Kf of water is 1 point. So you see delta Tf, find freezing point of solution. Delta Tf is equal to what is going to be Kf into, that is in the term of molality, is small m, molality. This is molality. So what is delta Tf also we can divide. So N2 divided by number of moles of solute dissolved in per kg mass of what? Solvent. Per kg mass of solvent. So mass of solvent in kg. That one also we can divide now. Mass of solvent in going to be in kg. Can we write like this?
Yes.
So delta Tf, here Kf is also there. That is, don't miss. This is Kf. Otherwise, you put the value of the Kf. Kf value already given in the question. How much Kf there? 1.86 is there. Water we know already 1.86. If you are multiplying here the N2, how many? 0.5 mole, 0.5. If you are dividing this one, mass of solvent in kg, how many gram of water they have given? 200 gram. Of 200 gram of water, you need to divide by 1000. This is the, if you are dividing by 1000, 20 cancel out. So it is going to be, here is 1.86 multiplied by 0.5 divided by 1 by 10. 2 by 10. 2 by 10 means 1 by 5 means 0.2. Yes or no? So 0.2, if you can cancel out this one. So it is 186 multiplied by 0.5 divided by, it is going to be 20. Now, if you solve this one, I remove the decimal. That is why this is coming like that. So this will 2 9 ja 18. 2 3 ja 93 into 0.5 divided by 10. So obviously, what is going to be the answer? Here is 5 3 ja 15. 5 9 ja 45. 45 and 1. This is 46 divided by 10, 4.65. 4.65 Kelvin. Can't you understand this?
Yes.
Are you getting?
And so keep the slide. Keep the slide. Sir.
Now let's see. 4.65 Kelvin. This one is coming. Slide. Keep the slide. Sanoya, I'm keeping the slide. You see. Done.
No, sir. 1.86 into 0.5, 200, 1000. Sir, done.
Okay. So this is there. This one is correct one. Okay. Now you can see this one and some more. There are many questions are there actually. So what the similar question are there, what you need to do. This I will share you, the PDF I will share you. Here, this also you will be able to do. I'm checking whether any difficulty question are coming. This one already we have done. There is one more question. This is good question actually here. That one already we. Just checking if any good question are there, then we will try. 1 gram electrolyte, non-electrolyte, 50 gram of benzene. This one 26. See the 26A. We are going to do 26A. So I am doing myself because you may find difficulty. They are saying 1 gram of non-electrolyte solute dissolved in 50 gram of benzene. So obviously they are saying that is 1 gram is there, and W1 they are saying 50 gram benzene. They are saying lower the freezing point of benzene by 0.40 Kelvin. I think we have done this question or what? 0.40 Kelvin you did a one question. Freezing point depression constant they have given. What is Kf they have given 5.12. Find the molar mass of solute. It is very simple. They ask in the exam C, Roorkee exam IIT 92 also. So what you can do, delta TF is equal to Kf into W2 into 1000 divided by M2 into W1. Okay. So you see what other things we have to do. They are saying freezing point. So find the molar mass. Very easily you can get now. M2 is equal to Kf 1.8. Sorry. Kf they have given something 5.12. So this is going to be 5.12. W2 already there. How much? 1. Multiply by going to be 1000. M2 they are asking delta TF going to be down 0.40. W1, how many? 50 there. 1010 cancel out. This is the 20 time. If you remove the decimal, this is 512 divided by 20 divided by this is going to be 40. This is going to be divisible. Okay. So what is going to be? 2 2 ja 4, 2 2 ja 4, 2 5 ja 10, 256 gram per mole. Unit is molar mass unit is. So this is coming very simple. That I think, see 256. The second part is also quite important. Let us do the second part. You may find difficulty. Calculate the temperature at which the solution containing 54 gram glucose into 50 gram water will freeze. So freezing point they are asking. Freezing point of what? Freezing TFS they are asking here in this question. Can you do? Can you understand this question? Or should I do? At least you do. If I will do, then what you will do?
Let's see, then I'm only doing.
Okay, let. No problem. So W2 they have given 45 gram. No, 54. This is not 45 actually.
So this one we did only, no? Just little time ago.
So we did the second one we are talking. Second one also done. Second one. Tell me fast.
Temperature 54 gram of glucose. Taking to calculate temperature at which will freeze. No, sir, you do this one. I don't think I can do.
So see, that is calculate the temperature at which solution containing 54 gram glucose. So W2 they are talking about 54 gram. M2 is equal to how much will be there? 180 gram per mole into 50 gram of water. So very simple. W1 is equal to 250 gram. Okay, this one. Kf already they have given. Okay, Kf how much? 1.86. So you can first of all you calculate delta TF. So what will be there? Kf into what is going to be W2 into 1000 divided by it is going to be M2 into W1. So Kf you see Kf 1.86 they have given now. W2 they are talking about 54 multiply by it is very simple 1000. M2 already you got 180. W1 already 250 given. 1010 cancel out. So 4 time it is going. So it is going to be very simply, it is going divisible actually because all are the even number. So this 2 times you can go send it to 90. If you are again sending this one 45. Okay. So here is what is coming 1.86 multiplied by 54 divided by 45. Now the down one it's still it is divisible. If you see this the 1.86 it is divisible. Okay. So with what number? With the 3 it is 3 or 5 3 is it is going to divisible. So here you see 3. So 3 6 is 18 and 3 2 is 6 divided by 54 3 1 is 3 15. Okay. Now we need to calculate this one. This is not you can calculate if you know how much you can get here. So 0.62 multiply by 54 divided by 15. It is coming 2.232 Kelvin. Now, question if you read, they are saying, here question, calculate the temperature at which solution containing this one, water will freeze. Freezing point of solution they are asking. Because freezing point of the pure solution solvent we know. So delta TF is equal to what is there? TF naught minus TFS. So TF naught is already there, na? Here, this one you already calculate 2.232. TF naught 2, what is there? This is going to be 273.15 minus what is TFS? TFS bring out here. TFS is equal to 273.15 minus 2.232. So you can see 273.15 minus 2.232. So it is gone out the 270.818 Kelvin. This is so if you are adding how many gram for 54 gram of sugar, then it will the freezing point will be reduced. Here you can check the answer also. Maya. Delta TF they are talking about 2.23. So in the if you are calculating in degree C, it is coming minus 2.23 degree C. But we have calculated in Kelvin. See, are you getting this one?
Getting, sir. That depends on the unit we are taking, na?
So what I'm going to do, I'm sharing this PDF to you. You go through the PDF, and and you again reconnect with me. I'm going a little bit out. 10:30. You rejoin 10:30. Okay.
Okay.
So we'll study one more topic. A little bit. I'm going further something. So this is I will say no. Wait. Depression in freezing point. TFP. So you can check your this one WhatsApp number, okay? And on this
Okay.
WhatsApp number, I am sharing this one. What? Just a bit.
Nothing came, sir. Nothing came.
Nothing came, is it? But I sent the document.
Both the
is it?
numbers are nothing came.
Acha, acha, acha. Wait a moment. 8:30 you that is 10:30 you rejoined, right? It is going now. It is it's taking little bit time. So you solved the sum of the problem and then you rejoined. Get it? Oh, okay.